this. So like each time, oh, it still asks me to authenticate it because I ran it under sudo, but I have the alignment, and I don't know what to do with these files to continue our analysis. But I also, just before we start getting into that, wanted to show you that I went into, is it RNA-seq? Yes, I ran all the GC for C1, all the C1s till C5. So I have a lot of analysis here I have to go through. From what I saw, I didn't see any significant changes. I spoke, can you hear me? Oh, I can't hear you, but no, I can't hear.
Can you hear me?
Yeah.
Can you hear me? Okay, good. So you can you don't find any significant.
I don't find any significant changes. I will show you one thing that maybe I want to see if I can interpret that as significant. But I spoke to my director, and he says if these treatments do not affect significantly gene expression, but they do affect splicing, it would be a great finding.
Yeah, that's what I felt as well. Yeah, I was thinking it may be good to show that you don't find any changes, and you focus on our splicing changes.
And exactly, and then I want to ask you, like a graph like this that has a table like this. Let's see if I can get bigger.
Yeah, I can see it. Yeah.
Oh, is it of any interest? Because it goes up to 0.7. Most of the samples are in the same group. There's only a couple samples that are not. In this picture, you can see that there's a significant change in almost all things. So
yeah, that's right. I think this one is kind of at a borderline of significant change. I think because some of the genes, the expression level are not highly reproducible, like the PTK4 and MPC2, and some of them. So and also I think it's also because that you only have 2 replicates. It's kind of easier. It's harder to get a significant change with 2 replicates. If you have more replicates, then the p-value will be more friendly. If you have like 2 replicates, then the p-value will be kind of harsh.
Yeah.
Yeah. So it's, I mean, you, yeah, I feel it should be okay. It's up. I think you can keep all these results, and then after and then we can also try the DSeq2 and see if because in general DSeq2 will give you more higher delta the fold changes and smaller p-value, and then so you may get a more significant like a metric.
I just wanted to see if I was taking the right approach when looking at this.
I
have still lots of results to look through because I ran like 50 different tasks. DC.
Yeah.
You see everything against everything.
Yeah, it's a lot.
Yeah, but here, I ran these. I didn't run it with the memory. The parameter you sent me, but it was heavy on the processing power because I did see the computer slow down. The only thing, nothing else to do with this computer in the meantime, so I just let it run and take its time.
Yeah. So it can still finish without any error.
Yeah.
Yeah, then it's fine. Yeah.
And now I kind of want to get into splicing and start what we can analyze, unless you want to go through DSeq2 first.
No, we can move toward splicing, and then in the end we can come back to the DSeq2.
Okay.
So DSeq2 is kind of a backup plan if we don't find anything interesting in splicing, and then we can try DSIG2 and see if the gene expression can tell us something.
Perfect.
Yeah, but before that, I want to show you a tool that can show you the quality of your sequencing runs.
Oh,
Yeah, so it's
that's
kind
good.
of a good quality control that shows some plots. Let me the tool is called FastQC, I believe. Let me see. Let me find it. Oh no, multi QC. So let me send you a website from the chat. I think you can
Once you run the alignment or before you run the alignment?
after you run alignment, and then you just run this tool at the in the folder where you run alignment. Then
Yeah.
it will kind of collect the informations about the alignments and show you how many reads you get, how many reads can be aligned. Yeah, so you can just install. I think you just need a command to install it.
Yes.
Yeah, you can just pip install multi QC.
Will it run?
P,
If it will run, do I have a pip command?
if you don't, you can just install it. It should be very easy to install.
No, I do not have
Yeah,
pip.
yeah, you just should do apt install Python 3 pip. Yeah, it should be straightforward.
Is it apt install like this or?
Yeah, just like the see there's a line here. Oh, just it shows in the on the terminal. It shows the command already. Did you see that?
No.
I don't see your terminal now.
Oh, here it is.
Yeah, like here. See?
Ah, okay. Apt install
Yeah.
Python 3 pip.
No, dash. Yes.
PIP. It's because the my keyboard is in Spanish and I'm using
Oh.
a US keyboard layout, so I never know.
Oh, interesting. Yeah, I never used the Spanish keyboard before.
Yeah, and I have an Italian computer here with an Italian keyboard as well.
Oh, cool.
Confusing.
Yeah, so this one you just need to create a folder and then put all, but right now your alignment files are in separate folders, right?
Yeah.
Yeah, so you need to create a link. Let me open a new terminal. Oh, it's already done.
Yeah.
Okay, that's good. So these are all the folders, right? So we can create a folder like a BAM folder, and then you can find all the files.
Say star. Yeah.
Yeah, like with a name like BAM. Yeah, BAM here, and then execute, and then create a link. I think create a link.
There's some magic happening here.
Yeah, it can be kind of maybe confusing. I forgot it's like 2 or 3. No. Yeah, let me try the first half first. Yeah, so this command can find all the files with with this pattern, like with a star means everything, and then BAM means the file end with BAM
Yeah.
in its name. Yeah, and then unless it's, yeah, even if I cannot create a soft link. Your exec, let me check my command. I think I remember it's exec. Oh, I think in the end I need to oh, there should be only one. Okay. Wait. It didn't work as I expected.
Could it be because you need to, it's locked under sudo privileges?
Probably not. Yeah, let me see. So you only have only a few bin files, like 8.
8 should be.
Yeah, so
yeah.
Yeah, so it should be file exists. Is it because your Ubuntu is different? Shouldn't be. Let me check again. This one. Yeah, I think my comments was correct. Somehow it didn't work.
Could I be missing a package?
I don't know. Let me try if this one works. It's okay. I will just. Oh, your copy is different from my copy. Oh, so your output bin file doesn't have a prefix. That's strange. It's kind of strange because
they're all called aligned by.
Yeah, the names are the same, so it's kind of confusing. So can you open the terminal again? I cannot see the terminal now.
Yeah.
Yeah, so I don't know if there's yeah, I think the alignment is worked and looks good to me. So can you show me the command you did, like again? I think I didn't notice the name. I think the output file name prefix, you didn't put the name after this folder name because this is a folder name. So either you can remove.
I made a new folder, then make a new file.
Yeah. So you can either remove this line, or you can add just. Oh. Yeah. So what
if I put
what I would
does
suggest.
that mean?
yeah, what I would suggest is that you can do like this. Like you put everything
Mhm.
in this band folder, and then under this band folder, you have the different name for different run, different samples. So when they save the file, all the band file, and then
Yeah.
the log files, like these log files, they will be saved within the same band folder. Then when you run this multi QC, then you can get the result.
Should I run
very
every?
easily. Should we what? Can you say again?
Should I run the script?
No, I think for now we can just manually modify the names. I think I'm thinking
Okay.
about how to do it. Yeah, I think it's kind of, yeah, or maybe, yeah, if you can click each file and then give it a name, then it will be maybe faster.
Yeah.
Yeah, you just need to
Like
rename it.
this.
Yeah, and then you put the star sample 25 or S25. Yeah, you can
This.
no, it's S25 dot, you need a dot before the aligned. Yeah, you can put that S25.
Okay.
And also you need to put the S25 for all the other log files, so the multi QC can recognize it.
Okay. So here's everything.
Yes.
Yes.
S25, yeah, and also the S, yeah, all the files. The star folder, we can ignore it. The folders are not useful anymore.
Okay.
Yeah, those are just temporary files.
And this one?
Yeah, this one as well, because we will need this file in the end for splicing analysis.
Okay.
Yeah, and yeah, this is the one folder, so you have to change all the other folders.
26. Oh, this is a little different. 26. I'm going to do this. Control C. How many samples do we need to start this?
I was, you can do all 8 of them, because we can run the multi QC for all of them.
Okay.
Yeah. Yeah, because redoing alignment takes a long time. It doesn't make sense to.
Yeah, I started on Monday. I finished yesterday.
Yeah, so I think changing the name is the fattest way to do it. Yeah. So that's all the I remember you have more than 8 samples, right? Is it only 8?
It's because it's only 8 samples, but it's to paired and read, which is why I had 16.
Oh, so you only did 8 samples.
As in, I did all the samples, but I only get 8 analysis because I have the reverse. Sorry, I have 2 samples. 2 reads per sample.
Yeah, but the number of samples is 8.
Yeah,
Oh, okay. I thought it was more.
it's because it's 4 treatments.
Yeah. Two replicates, 4
2
treatments.
replicates. Yeah.
But don't you have the control sample? Is the 8?
Yeah, the control is one of the 4 treatments.
Oh, I see.
Oh. Control V. Rename. The idea behind this RNA-seq is to see if there's anything interesting going on, and if there is, go back to injecting the mice with and checking more organs.
Yeah, I see.
Which is happened. Okay.
Kind of strange because
yeah, I don't know why it asked me.
Yeah, I shouldn't. I mean, if it asks you because I think it's already like 1 minute or something. There's a time limit for you to run to make modification as a super user.
Okay.
Yeah. So I think that's just past the time already.
We're almost there.
Yeah.
Sorry for making you wait.
No, it's fine. Yeah, I think it's the
last one.
Like you did alignment in a few minutes.
I think there was an error with the sample.
With this one, 32?
Yes, so it doesn't have the same number of files. It doesn't have this one.
Can I see again? 32. There's a BAM file, but it doesn't have the index file. So it means that it probably didn't finish. So if I check, oh, can I click? Yes. So I should check the log, because the log file should, if you don't see the log final file, then it means there's something wrong in the middle. Yes, I think it didn't finish.
I think it might have run out of space on the main disk, which is why I moved everything to the other disk.
Yeah, so this one you have to rerun.
Okay.
Yeah, so can you go back to the terminal so I can just link the file and then use the MultiQC. Oh.
Yeah.
Yeah, we can use another link later.
Let me just press OK.
Yeah, you press, I cannot press it.
There you go.
So the command now should be able to find these files. So I have to use the execute, I think. Hard link not allowed. So we just need to remove the first one, which is the failed run, the 32 failed run. And also we need to copy the, so I think what I did was just create a link.
Yeah.
Or yeah. So this is hard link. Let me remove them. I hope to use just the soft link.
What's the difference between a hard link and a soft link?
soft link is like a shortcut, and when you delete this file or make a modification of this file, it doesn't affect the original file. But a hard link, if you made a modification, it can affect the original file.
Okay.
So it's better to use the soft link. Yeah, and then I think the BAI also needed. The BAI file are the like index file for the BAM file. For each BAM file, there should be a corresponding BAI. But you don't. I thought you have BAI files. Oh, you did. You don't have BAI files. I think because you only did alignment. In the end, you still need to run a command to create index. Yeah, I can show you now. Can you go back to the terminal? I cannot
Yep.
see. Yeah, and yeah, so all these are the BAM files. I'll remove the first one. This one is not complete. So usually you just need to use same tools index, and then use the one of the name, right? And copy the paste. Yeah, then you should create an index file.
Okay.
Index
file different from the genome, the fast, what is it? The FASTA file and the BAM, no, the GTF.
Yes. No, it's different. Yeah, this index file is belonging to this alignment file. So this alignment file is fairly big. So it create an index file for when we want to access this file, it will look for where the specific chromosome is in this alignment file, because all the reads, they were sorted by their locations. So if the read that alignment is at a specific chromosome, then they will be grouped together. So you just use the index to find them. Oh, this is kind of slow. It's okay. So, but I think for multi QC, you probably don't need it. I guess. Okay, look. Yeah, these ones are not useful. So the multi QC should read these log files and then tell you how many reads you get.
Okay.
Or you haven't installed the. So you only installed the PIP, right? You haven't installed the multi QC. So can you install the multi QC? Yeah, you just need to use the PIP install, and also you need a super user, I think.
Okay.
Yeah, remove the yeah. I think you need a super user. Yeah. And this multi QC software is pretty useful. Even you just put the FASTQ file or BAM files, the log files into one folder, and you just run this multi QC space dot this command. It will look for the FASTQ and then BAM files in this folder, and then I give you a summary of this all the files. Yeah, so
fantastic.
Yeah, so now you can just use the multi QC dot, and it will, for BAM files, it will read the log file, log files. Those are the kind of summary of the alignment. And then for FASTQ files, they will physically read the FASTQ file. So now it is down. It will create a report. Yeah. So if you go to the folder, you can just click this file.
Let me see.
Yeah, the more space on the BAM file folder. Yeah. Yeah, and the second file, yes. Huh? It become Googling. Can you go back to the folder? I think we just need to open it with a browser. Yeah, I think open with Firefox should work. Maybe you can just copy. Yeah, just copy this address.
No.
That's strange. So do you have any other browsers?
Let me see. I should have the.
That's the only one. Or you can go back to the Firefox and then try to find the list. Yeah, I see the same. So Firefox should have I think there should be a open file option. I think.
I'll let you do it.
Yeah, let me see if this open and files. Yeah, so this one, the files works. So do you know where it is?
Yes, but it's under the
media. Oh, media, right? This one. This one, media.
Media, Pepe, or space 2.
Yeah, and then the HTML.
Report. Oh, there we go.
Good. So you can see from this report, like for most of the samples, they have like about 80% of the reads can be aligned to the genome. And the second column shows the number of million reads aligned. So you get about 40 million reads per sample. So this is something you need to report when you write a paper, like in average. You get how many reads in total, and then how many of the reads can be aligned. And the other one is alignment scores is showing that how many of the reads can be uniquely aligned. Like this is showing the darker blue shows like 80% of the reads can be uniquely mapped. So the reads are mapped to only one location on the genome, like not many other places. So this is good. Yeah. So this is just a simple report you will need in the end. Yeah.
And is this would I say the quality of the reads is good enough?
Yeah, this is good. I think the 80% aligned read, 80% is good. Yeah. Sometimes I think in some of the RNA-seq data I have seen like over 90% or even 95%. So but 80% is good.
Okay.
It's already
as long as no one's gonna say the quality of your data is not good enough to analyze.
Yeah. So this one has